Well, now we will start with the pre-processing. So we will discuss about what is pre-processing and where it comes in the sequence of building process, right? Okay, now definition. C preprocessor is an engine which is executed as the first stage of C application building process. You need to really underline or note the word application building process. It is not compilation process, because as the name itself, it says that pre-processing. So what is so pre-processing means it is doing something before it is executed before some processing. So what is that processing? Compilation processing. So the name itself is very well suggesting that it cannot be part of the compilation process. It is beyond or pre-compilation process, right? Or to expand it, I would say C pre-compilation process. So it's an engine which is executed as first stage of C application building process. So we have carefully coined the term application building process because the building process which includes pre-processing and compilation process and then the linking phase, right? Some books may suggest that or may place the pre-processing as also a part of compilation process and also the linking as a compilation process. So it is very incorrect. So if you have really come across those kind of learning, please better unlearn it. Now we'll proceed. As part of its matrix, C provides some directives which has to be processed before the compilation process starts. So this is done by the preprocessor. So these directives actually has very many use cases for programming, right? So they have introduced this. We will see one by one what it is. So following are the few directives provided by the language. So to name it, we have define, include, error, etc. So usually as part of the syntax, hash is the one which is precluded before the preprocessor keywords define, include and error, or hash is the one which hash will be precluded before the preprocessor directives. So usually the normal thing is we always say hash define is preprocessor directory. It's actually defined. Okay, now we will look at the include directive of the preprocessor. This is the preferred way to tie the declarations together for the target C file. This is the preferred way to tie the declarations together for the target C file. Looks to be highly technical, fully loaded definition for the one to really take it for the first time. See, what does it mean is you already know that we have in a program, before invoking a function, the function's prototype or declaration has to be defined somewhere above the usage. Suppose in the main function I invoke a function called printf, it is usually mandated by the compiler to define the prototype before invoking it, so that it will be easy for the compiler to do a type checking, right? So it will be so tedious to fill all those declarations in a C file only, right? It will be too cumbersome also. So the best way is usually we write a header file, dump all the declarations there or function prototypes which we will be using in our C file, and then include that file in our program or in our file. What does the include do? In the pre-processing stage, preprocessor will just open up the file, dump all the declarations, type defs into a temporary file, and give the input to a C compiler. It will give input to the compiler. So all those together is called tying the declarations together, right? We shall see an example now. Standard stdio.h. Shall I minimize this? Okay, I have included stdio.h, right? So though what I have done is the library provider has also provided the libc, the C library provider has also provided stdio.h, which includes all the or most of the prototypes whose functions are defined in the library. For the first timers, just observe or carefully listen to this point. Header file will only contain declarations. It's a normal habit to jump to a conclusion that the library functions are defined in stdio.h, especially the printf. So once again, only the prototypes are defined here or declared here. The definitions of those functions will be defined in the library, C library. Okay, to just show you to you, it will be somewhere here. Libc, this is the library. Shared object file. When you go to a toolchain session, you will know more about this, but for now your printf function will be defined here and whose declarations will be here, right? Usually stdio.h would be for Linux machine, it will be here. So the compiler or the tool which is used for compilation building, typically GCC, would be knowing about this. It's for GNU Linux operating system or GNU/Linux operating system. This is a standard folder where all the header files are placed, right? Now shall we pre-process this? GCC -c, if I say what is the file name, pp.c, you can see the preprocessor will just dump all the contents of stdio.h. Contents in the sense only the what I should say, the declarations and the type defs will be dumped. So see, I shall redirect to something pp.x. When I do a vim, right, our code is only 4 lines. The remaining 846 lines have been taken from stdio.h and the recursively included header files. I repeat, all these lines, all these declarations which we are seeing here has been included from stdio.h as well from the header files which are included within stdio.h recursively. So suppose stdio.h, so okay, I will also show that. stdio.h, okay, this is stdio.h. It will also include bits types.h, stdef.h. So the preprocessor has to go to that file and then include all those definitions. And suppose stdio.h would have included some more header files. So recursively it will go till it sees an end. Declarations as well as this kind of type defs, start, all will be included. lib.io.h. So like this, how many of these header files recursively it includes? There is also an option to see that. We will see that in a short while from now. But I want you to observe that, see, when the preprocessor is finished its processing, you can see all the prototypes, right, and the type defs here, type defs can be seen here. So the most interesting, you just have a look at this. It may be of some help to you later on, and this is part of libio.h. okay, and the most interesting thing would be, you will be keen to know about printf declaration. See here. So this is easy for the compiler to do a type checking, right? So declarations are there only for the compiler to do a type checking. All right. Now, so how many of these files are recursively included? Okay, that we shall see in a short while from now. Okay, there might be around, if you really want to know how many declarations are there, just out of curiosity. When we said that prefer to tie the declarations together in a target C file, so all the declarations are tied up in stdio.h and its recursively included files. So how many of that can be there? So if I want to tell that, shall we say okay, I can give an approximate count. Cat pp.x, this command you would have learnt, but still I would grep one second, grep extern. Okay, this will list all the, apart from prototypes, this will also list this. What if sometimes the function returns struct? Okay, let me give a count here. Okay, these are all only this. Okay, I can eliminate this. Grep minus v. One second. So this will give me only declarations. I'm just giving you a feel of how many declarations can it be you can have. You do wc minus l. 109 declarations are there in stdio.h and its recursively included header files. Just imagine all these 109 declarations. If it is part of this file, how cumbersome will be your C file. And this is a story of stdio.h. If you can include some few more header files, gone, your C file will be looking very clumsy. So to make it much more readable, I think it is better for us to tie the declarations together in a header file for target C file, right? All right, we'll proceed. Okay, I was talking about how to find out recursively how many header files are recursively included. Usually there is an option called -m. This option has the requirement of this option has come from a make utility, right? Okay, and moreover, one more thing, searching for the header file stdio.h by the build tool will follow an implementation defined rule. So implementation defined rule here is, I would say it's a GNU/Linux implementation defined rule. That means in a short while ago I was telling that the stdio.h is there in slash user slash include. This slash user slash include is an predefined folder where the header files are stored. So GCC will know that, okay, on GNU slash Linux I should start looking for the header files from user include only, or if you have specified some folder, that will follow that. This is about searching part. Now the next part is to know about the recursively include header files. For curiosity, we knew that, okay, it's 109 declarations we have, right? Now obviously if you are so inquisitive, you want to know how many recursively included files are there, and this option has come from a GNU make utility, okay, for its own known reasons. We will be learning that later, but we shall see here gcc -m pp.c file. So we ignore about the format of how it has printed, but if you just calculate 1 2, I don't know should I include this or not, but again start from here: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 header files are recursively included, right? And see, everything is user include, user include, user include, user include. Okay, there is one difference here, okay. So everything is found here. So there are 15 files, right? We shall proceed. This is just to answer your or to subside your curiosity. Now build tool like GCC searches the file name.h in the current directory. Of course you have to only look at the formatting here. If you specify in the angle bracket, the tool will look in the predefined folders. If you specify within quotes, it will look in the current folder, okay. Now macro substitution. Define, okay, what is it, macro substitution? So it will help the programmer not to hard code the value within the program. Suppose there is a max file of 256 you want to define, so it doesn't mean that. Advantage here is you want to use this 256 at around 20 places in your program across some n number of functions. So instead of hard coding it, there is a preprocessor directory called define, which you can define a name or a symbol for this value. So advantage, that multiple advantages. One, you can avoid hard coding of this value in the functions. Second, if you want to change the value in future, you can just change at one place instead of changing at 10 or 20 places. This is the use, and I want you to experiment and feel this, okay. I want you to at least define around 2-3 functions, hard code the variable, hard code the number 256 at your own use case, and see if you want to change it to 512. How many times you have to modify it, and advantage of using max here, right? So this is one directory which will be helpful in very many cases, and most prominently used, I would say, if you ask me what is the most prominently used macro after include, it is define. And what you have to remember is the scope of the symbol which is defined within this defined directive is from its point of definition to the end of the source file. A quick example I can give: if I say define max here, I can use from here till the end of the file. suppose it's the same thing, I would say max equal to something if I use it here, this will give an error. There you go, max undeclared. So this should help you to understand the scope. The scope will be from this point to the below point, so this will not know what is max value, right? So we need to be careful about this. So of course it will work now. Next, macro with an argument. So obviously macro can be used with arguments also. So most commonly used macro, each occurrence of the formal parameters a and b are formal parameters will be replaced by the corresponding actual arguments. So when you use this in the program, then I would say the arguments passed there will be actual arguments. I think it's mentioned here. And the below macro usage p plus q and r plus s are actual arguments, right? So this makes the code very much readable, neat, right? It is self-explanatory. Caveats while using macros: better be very careful when defining a macro. Use obviously the brackets. So this is also, I should say, defensive programming, right? You just pass increment operator. You should be very careful while passing increment operator, unless otherwise it is useful. So better be careful with this, right? You will get the undesired results here and here also without using brackets. If you do x plus 2 star y plus 3 star will get a precedence and you will not get expected value. So what is missing here? I just want you to think how will you correctly define a macro with the right usage. Okay, be defensive always. Nothing wrong in being defensive in life. Stringizing operator, okay, rarely used, but we have a use case here. Okay, the first statement, formal parameter not replaced with encoded strings, that is unwarranted as the first statement, but anyway it is there as part of a slide. What does it do? First we will see, and then this is actually an exception here. See here, the value what you pass, you can make it as a string. That's what it means. You pass here dprint x/y, alright. When the macro is expanded, it will be like this. So both strings can be concatenated and made as one string, right? This is actual usage, but the exception is, or the clause here, formal parameter are not replaced with encoded strings. So you will be very careful here. You have expr, you can replace it here as a string, but it cannot be replaced here. See here, carefully observe here, #expr within quotes x/y, but this expr is written as it is because it is not replaced with the formal parameter. That means here it would have been x/y, right? That is what the statements tell, right? Move on. Token pasting operator, again very rarely used, but still you can see use cases. Is a preprocessor operator which provides a way to concatenate actual arguments using macro expansion. I mean, we can treat it as a variable also here, but in the kernel code you can see all these things used most frequently compared to application code, but still int marks underscore chem, and you can see here marks chemist comma 0.08. So the variable will be marks underscore, I mean it's used to simplify your code, right? But I would always suggest don't write a code to make use of this, right? Find the right use case to make use of this. Since there is an operator, you should not make use of this. If there is a need to use this operator, definitely you need to be aware of this and you should make use of this, right? Okay, I wanted to experiment all these things. Interesting though. Okay, there are some of the conditional compilation directives which we oftenly used, especially when we are writing a big code or we are writing a portable code to be, I'm giving an example. Hashif, these are some of the conditional compilation directives. In the following slides, we will show the right usages of all these things, right? Hashif and if to comment a block of code, right? You can see here hashif 0. I think by now you should have known the usage of this, right? This is the best way of commenting block of code, right? Very handy way. If you are a developer, you cannot do away with this, right? Example for hashif and if. So this is what I was telling about portable code. If it is x86 32-bit, you just include this header file, else you include this header file, right? Hashif defined, both are almost same here. This is the newer one, this is the older one, but still it has its own use case. If defined little endian, this is actually taken from a code in the networking subsystem. If defined little endian, this is actually a portable code, right? It can be used for both little endian machines as well as big endian machines. Unsigned char. See the sequence of the variable varies. First I would have IHL and then version. If it's a big given, I would have version and then the IHL, right? For you to get clarity here, I think this will get a better feel. IHL first and version next, and version first and IHL next. Else, if both are not defined, see, I am also making use of an error directive where the preprocessor only will throw error. Just it will print this. That means there is no point in compiling, right? So instead of this is really helpful because it will help to show you the error right away, or else the error will be somewhere in the code and it will completely misleading. This is the best. In this case, at least I feel it's a best directive offered by the preprocessor, so that the errors are thrown at the right place. So the preprocessor hits the error directive, it will report okay. This is all the text whatever we had explained previously. See, this is if hashif defined is useful when you wish to test more than one macro for existence at once. This is what you can compare to hashif def, right? So straightforward. Hashif and def most prominently used in the has a header guard in the header files. The best example, if this why it is used to ensure that the header files are included only once. If ndef this variable, usually these kind of variables are starting with underscores are used in the header files related to library code or the code itself. If this is not defined, define it and include html.h and blah blah blah, and then end if. Once again you try to include html.h in the same file, it will see that if it is not defined, if it will define, it would have been defined and then quietly come out. This is named as a header guard. You should remember that, okay? And to get some of the predefined macros, you have some here. end of file, date, time, null. So these are the predefined macros. Yeah, very commonly used macros. I should say it's for your information we have added here. And also some of the macros like file, function, line. I want to execute this code and see what is output. And I also want you to look into these macros in your stdio.h and see what it does. Right? This is interesting. Maybe you would have been hearing for the first time. You can also pass the macro definition using command line arguments using -g option while compiling or pre-processing. Experiment this. I would want you to experiment this and see how it works. Right? Oh, there we are. We are at the end of the session, and yes, thank you.